Wait 1 minute. Yes. Yeah. So one more way of providing this microbe sculpture or providing this biological system is attached growth method. So how would they provide that? So the stones, some stone material will be there, no, like this coarse material stones. Okay, so this is something as a filter bed. Everywhere we will use, right, this thing. We call it as what? Filter bed. This is coarse material. We call it as a filter bed. So what happens here? So see here, some growth of microbes also happens above this layer. Now above this stone layer, microbes also can grow. Why they will grow? This whole system, we call it as a attached growth system. Why? Because the microbes are attached here in a coarse material or any filter rigid material. So if you supply any wastewater here, what happens? Any wastewater if you supply, so microbes will be there here already. These all microbes is there, no? They will try to treat your wastewater. All microbes, there is one layer will develop. Above this, one layer will start developing. So it will called as biofilm. Okay, biofilm. After certain time, this biofilm will develop above this all coarse material. So they start this act like a filter media, micro filter media, and they will convert all waste into liquid and gases. So this is a concept. So using this concept, they will develop this technique, trickling filters, okay, or percolating filter or sprinkling filters. So to explain this, I will directly take you to the figure. First, before that, I will try to clean all the these diagrams. Wait, yeah. So see, this is how the figure looks. You're seeing this figure. So this is how this trickling filter looks. Yeah. So here, what you're seeing, some coarse material. Wait, I will try to share one more thing is there in my video. So this is nice way of telling trickling filter. Ah, I think this is good. This is how your trickling filter looks. You seeing now? So here, what you seeing, some coarse material, right? Yeah, this is our coarse material, some stones, right? So this is the top view of this trickling filter. So what happening here? So see here, this is all rotating distributory arms. You see this, no? Rotating distribution arm means they are rotating here. Four arms will be there, no? And inside this, some nozzles are there here. Some micro nozzles are there here. Also, some nozzles are there. Just like drop irrigation or sprinkling irrigation, same like this. The wastewater is sprinkled through this filter media. You see, this filter media. So here it will be sprinkled. So when it's sprinkling, it will try to interact with oxygen. The atmosphere oxygen will be there, no? So there it try to interact and it will gain some oxygen, right? So that is how it functions. Some oxygen will be there. So traditionally in the previous method, we used to enhance the oxygen level, right? We used to provide some diffuse aeration method or some variation. We used to install some pipes, so we used to give oxygen. But here the oxygen already there, so in atmosphere, so we're trying to make that every drop will get exposed to environment oxygen, so it will gain oxygen and here it will fall in a coarse bed. So what happens here, after certain time one layer start developing, it is called one layer start developing here, it is called biofilm, seeing above the coarse bed. So this is a layer, very important thing, where microbes start developing. Because of it, all waste, they start eating it as a substrate and they will convert it into simple carbon dioxide and water. So this is a way how this will work. So now seeing this figure, so you have questions like explain trickling filter, explain construction working of trickling filter. So like the two questions, or removal mechanism of trickling filter. So three way of asking questions. So normally, generally they will ask explain the trickling filter. So very important question. This one and previously what I've done. So you got to know this. So where the pure water collected then? So you're seeing the effluent to SST. Here all pure water start coming and it will be further go to one more settling tank. You know, one tank will be there, one treatment unit will be there. So something will goes on. One more tank they will provide again. So this is how usually your treatment will look. So here secondary clarifier sedimentation tank will be there. So it will pass to here. So further settling will happen. If anything is remaining, it will settle into bottom. Or if you want directly, you can take from one provision effluent collecting tank. Here only we can make to collect, or you can pass to the next chamber. So one more you're seeing it is called laterals in the figures, right? So this is what these laterals are used when when this filter get exhausted. Means we have to maintain the filter after some time. So here what they do, uh, actually these laterals are it's not get exhausted. Actually here all waste percolating, right? All waste as a pure water, so it will reach to here through this lateral and it will be having some slope like this. Okay, so some slope it will be like this. So because of this lateral it will be collected and it will move to the main chamber. So and it will be collected to the effluent tank. Okay, so that is the function of these laterals. Okay, I think all of you got to know this. So then if it get exhausted, then what they will do, they have to remove this biofilm. And one more process I forgot to tell. So after certain time this biofilm start growing up at a higher diameter. So what happens after that, it will be peeled off. Simply it will come out as a layer and remove itself. It is called peeled off. So that is there. The biofilm will come out when it increases in dia. So it will be peeled off. Okay. So that method, that is a part of this process. After a certain time, the biofilm grow up at larger diameter. It will come out like this above and it will be peeled off. So and then when they are maintaining this trickling filter, what they will do, so they have to scrap this. You're seeing this above stones, right? So they try to remove these stones and they try to replace these stones. So that is how they will maintain. Any maintenance issue arises or any efficiency of these filters get reduced, on that time they will do that. Okay, so now you got to know about this. So the same like this, you have one more concept called rotating arms. It is also works in the same principle of attached growth method. So I will try to do that now. So yeah, so you have to practice this diagram. So this is trickling filter, rotating arms is there. They will be rotating 2 rpm per minute very slowly and it will percolate to filter media and it will central effluent, it will be collected to this lateral. So here the pure waters will be stored, or if you want to further treat this, they will send it to next process. secondary sedimentation tank. Okay, so this is how they rotate. So one more concept you have just like this is called rotating biological contractors. So this is a thing you see now. So one more concept is there. So I'll try to do this now. So what is rotating biological contractors? You already got to know some contact we are making up with the sewage and with the oxygen and microbes. So three parameters you're studying. So here what happens? So first they're telling where it is invented. It's invented in 1960 in Germany. So RBC are rotating biological contractors. So it has a series of closely spaced circular disc of polystyrene or polyvinyl chloride that are submerged in wastewater and rotated through it. So one cylindrical rotating disc are there. Like this, many discs they will place and it will be rotating in the wastewater. It will made up of polyvinyl chloride, this disc. Okay. So cylinder plastic discs are attached to horizontal shaft and are provided at the standard unit sizes of approximately 3.5 meter diameter and 7.5 meter. So some dimension they are given how it is placed there, and surface area of this for standard they're given the surface area, this whole you're seeing this no surface area. So they're given this much. Then what happens here? So you're seeing since it's rotating, oxygen it will gain right in the atmosphere. So one way it is mixing the oxygen with the available waste. So obviously the waste start treating the microbes will start treating the waste and they will convert into simple form. So that is the concept. So what else is there? And yeah, flow perpendicular to the shaft or parallel to the shaft. To so these are RCB shaft. These are rotating, disc. You're seeing this part, and this is our tank. These are tanks. You're seeing part of it is this rotating this. Okay, so in this their shaft are rotating. They will induce oxygen to the wastewater, right? So all this is one way microbes can grow and they will convert all those waste into simple form. So they're given one more thing, how much they will rotate it. So it's very slow actually. So 1 to 1.6 RPM. You can think as just one rotation or per minute. Only one rotation it will make per minute, means 60 seconds. So mechanical drives are normally used to rotate the ones as this RBC disc rotate out of the wastewater. Aeration is accomplished by exposed to the atmosphere. Waste flows down through the disk and solids slowing occurs similar to the trickling filter. Same like trickling filter, waste flow through the disk and solids settling occurs or slowing occurs just like trickling filter. So this RBC system require pre-treatment of primary clarification screens and secondary clarification for solid liquid separation. So after providing many preliminary treatment, they will go for this method, biological method. So one way of providing this. Okay, so there is a two way you can do this: perpendicular shaft like this or parallel using this. Okay, so two diagrams. So yeah, so I think I covered three concepts today. With the two concepts are very important for exam point of view. I told you that also. So one problem will be coming in the tricking filter. Trickling filter problem you have, but I will try to do this. Uh, wait, anything is there missing? I will try to see. I'll go to the syllabus then. Right. Yeah. I think I covered biotowers I have to do. Biotowers, it will be similar to this rotating arms. Right. Anything I can use Google here. Right. Biotowers. So first I will try to tell you some images. I'll try to show you what I done till now so that you will understand better. Yes. First I will show you how trickling filter looks like. It will tell, see this is how your trickling filter looks. You see this now? Yeah. This is how your trickling filter looks. This is all rotating arms. And this is your course material. So the waste is passing here. See, nozzles will be there. So this is how it will looks. And above it, that layer will develop. So it will be peeled off. After a certain time, this biofilm will be peeled off. Means they will come out. So this is how it looks. Then one more, you have activated sludge process. I'll try to show the figure. Right. Activated sludge process. This is a thing. Okay, it's taking a lot of time. Yeah, I think I need figures. Yeah, here you're seeing this is how the activated surfaces look. They are recirculating back. You're seeing now? They are recirculating back. This is how continuous air is going on. Continuous aeration provided in the bottom side. So this is their recirculating back. So this is when you visit an industry, it will look like this. This is sedimentation tank. This is your activated cell process. This is all activated cell process going on. It will reach to your sedimentation tank or clarifier we call. Okay, this is how it looks in industries. So one more thing you have rotating biological contractors and biotowers. I will try to show the figures. Rotating biological contractors. Yes. So you can Google yourself. I think. Yeah. This is how the rotating biological contractor looks. Seeing no, this is a disc. Always pass through this disc, and since it will be rotating, they will get exposed to air also, and microbes start converting all sewage to simple form. So this is conventional disc. Okay. So we'll try to move on then. So some typical diagram they are given in Wikipedia. See this organics. This aerobic anaerobic disc media is there. This is all growth of layer happens. The treated water comes down. It all happens in the disc itself. Okay. So what else? You have a Biotowers concept. So I'll try to see that now. Same principle, Biotower. I just need this is trickling filter. We need Biotowers. Wait. Yeah, actually it looks similar to trickling filter only. The image looks similar to trickling filters, and sometimes they will construct it higher rate, higher height. This is all biotowers. Sometimes they'll construct like this. Okay. So one more way you're seeing this. This is called biotowers. see this. This is Biotowers. So same, the effluent trickles down over the media, which becomes coated with microbial film that consumes organic materials. Same like trickling filter, all looks same only. So this is how it looks. Biotowers, same like trickling filter, same concept. Okay. So I will try to give notes on this. I'll prepare and give you. But important part is again this trickling filter and activated cell process. Anyone you can expect in exam. These are if they want to twist anything, they will go for these concepts. But they, those two are very important. Every time they will ask. Okay. So what else you have then? Yeah, I think one problem I have to solve on tripping filter I will do in the next class. So I think one more concept is there slug digestion beds. I'll try to do that and I'll finish it. Okay. So that last concept, slug digestion bed is there. So what is sludge digestion bed? You know the sludge is collected, right? The sludge is collected in clarifier. Then how you will treat that? So that concept you will learn in the sludge digestion bed. It's here only, I think. It's not here. Okay. I think I'll try to do in the next class because the PDF I have to do that. Wait. Slide digestion bed. Slide digestion bed is there. Yeah, I think it came. So 2-3 minutes I'll do this and I will end the session. So now you up to know what you have understood is how you will treat the wastewater, but you have seen sludges continuously collected in each process, right? What is sludge? Sludge is the solid matter of your wastewater. Some sludge is collected in the primary clarifier and some process will be their biological process. Like one more clarifier they will keep. So here sludge start depositing in the bottom. So we have to treat this also because when you treat this you have a lot of benefits. You have, like you can earn money because when you treat this sludge you can earn money by because it will releasing what methane gas. all methane gas will be released when you treat in the sludge, so you can make money just by treating this sludge. Okay, so how they will do this, how they will generate energy through this, what is the process, we'll try to do it, understand now. Okay, so it's simply a closed vessel. You're seeing this now. If you see this is completely closed, right? It's completely closed vessel, and they will try to pass the influent here. Some supernatant liquids start forming here. Some active layer also there here, and gases also releasing. So you all see, you already know that in many process, if you keep it in a container closed way, the glasses start, you know, coming up. All the methane gas, sulfate gas, right? These are gases start coming if you keep it completely closed. So that concept they will use. So they just try to close completely, and they will keep it for some month, 1 month, 2 months. So there is supernatant liquid start forming. They will try to remove that, and after that, above this scum layer or oil layer, some gases start evaporating, and they will try to collect these gases, and they will use it for biofuel or bioenergy like that. Okay, that is the principle, and I will try to see this what and all it has. So I'll try to read this. See here. So sludge digestion tank. First, they are telling how they will made up of. It's a this is a tin tank of cylindrical shape with hopper bottom. This is a hopper bottom covered with fixed floating type roofs. The raw sludge is, this is the only principle. The raw sludge is pumped into the digester through pipes. It will pump through this digester through pumps into the digester through pipes through where it is mixed with digester sludge. Already some sludge will be there. It will mix through that. That's digester sludge is withdrawn from the tank bottom, and gases are decomposed. Chiefly, this methane gas and carbon dioxide are collected in the gas, and the supernatant liquid lying between the sludge and the scum is removed. The effluent coming, one more effluent will be coming, supernatant liquid, that they'll remove it, and at suitable elevation through a number of withdraw pipes as shown in the figure. So simple process, 2 3 line you can write, but figure you have to write like this. Okay, so some hooper RCC construction, there is a 3 layer, it will be formed. One digestion sludge already will be there, it will mix through that, and supernatant liquid will be coming out, they'll remove it, and major cheap gases like methane, carbon dioxide, they will collect it. So sometimes they will try to store this, and they will use it as a biofuel. Okay, so that is the concept. You have to, if they miss out this activated cell process or trickling filter, they will directly go for this concept, because it's very important concept, sludge digestion tanks. So yeah, so you can have this question also in exam. You can expect this question. Okay, so I think I covered the concept today. What is aerobic and anaerobic then? So if they are completely closing, the aerobic condition will develop. Sorry, anaerobic condition will develop. That is why they are collecting gases, and they are earning money and all. So if it is exposed, then also you can treat. It's a very slow process, but you will be not having gases. It's an aerobic condition. Okay, there is two way of doing that. So you can expect that question. Okay, so one more concept you have called sludge drying beds. Sludge drying beds. So this is the sludge drying beds. All sludge will be coming up, right? Come out. So what they will do here, they try to keep it in a field, and they try to dry it. Especially this is from clarifier, primary clarifier. Some sludge will be coming out. They will try to dry it with our in a field. Wait, I will try to draw. So this is I'm doing now, last concept. So open beds of land is called sludge drying beds. Drying means you all know what is drying means. You in cloth you will be drying, right, in the with respect to sun. Same like this digested sludge which is came out from this tank. This tank you have seen over at the bottom. So this sludge is coming out as effluent. They will try to dry that also in an open land. So, so that is the concept of sludge drying beds. So sludge drying beds are open beds of land. The diameter and all, I mean, the specification they are given 45 to 60 deep, consist 30 to 45 centimeter thick graded layers of gravel or stones like that. Spacing and all they will given. The beds are about 15 to 30 centimeter 15 to 30 centimeter of beds in a plan and are surrounded by brick walls rising about 1 meter above the sand surface as shown. The sewage sludges from the digestion tank is spread top of the drying beds through distribution throughout. It usually takes 2 weeks or 2 months for drying the sludge depending upon the weather. So this and all you try to understand, try to go through these notes, simple concepts. They're just trying to dry this and they try to convert into more solids. Okay. So with that, I'll try to end this session. If any figures are there, I'll try to see in Google. So and if it ends itself, I think last 3 minutes we have. Right, I will try to remove all this. So I'll try to show the sludge digestion tank and how it will look. So digestion tank, how it looks exactly. I'll try to show the figure. So this is how the sludge digestion tank looks. I think all of you are seeing right. Yes. So this is how the digestion tank looks. If you see in industry, you will see like this. Aerobic sludge digester. This is a tank. Completely closed. Okay. So this is how it looks. See, digestion tank. Inside, if you go, it will look like this. Okay. So what else you have? Sludge drying beds you have. That also I'll try to see the figure. Drying beds. So yeah, this is good example of sludge drying beds. You're seeing this, right? This is a sludge drying beds. This rectangular thing, they're just drying all the sludge with the sun. It will take 1 month actually, 1 month to 1 week. Okay. So I think I covered most of the concept. Thing remaining in the fourth model is the problems of trickling filter. I will try to do that in the next class. Okay. So I think it's a marathon class I have taken. Thank you for attending. I think it will be very benefited who have attended this class. I have shown figures also, and I will send this video. I have recorded this, and if you can watch it again if you need. Okay. So 2 minutes is there. Anything you want to ask, you can ask. In YouTube, you have a lot of videos. You can watch those, especially if you want to know how this looks like. YouTube, if you open, you have this lot of videos coming up. You can watch. Trickling filter. I think less than 1 minute is there. It will end itself. So you watched a lot of videos on this. This is how the trickling filter looks. I think this is not the exact video. So a lot of videos are there. This is one more video you're seeing now. This is how trickling filter looks. So you try to see videos after the session.